Okay, ladies and gentlemen, good morning. It's very glad to give you the training for V6 electrical control system. So I think this generation, maybe most of the customer know our generation. This generation we have sold for the market more than 4 years. So my presentation included four parts. First, the electrical control box. Second, the DC inverter principle. And the third one is the electrical component. The last one is control difference between V6 and the previous generation V5X. Okay, from this picture, we can see this is a electrical control box for V6. We can see this is the main component for the control box. From the left picture, we can see this is the main PCB. And the middle is the AC feeder board to filter the power supply. And this is the inductor on the AC feeder board. And the right side of the picture, this is the terminals of the power supply, the 3-volt, 3-phase. And in the bottom of the picture, this is the weak power supply. It's communication terminals, like connect to the power meter, connect to the indoor unit, and connect to the centralized controller, and also connect to the other auto unit combined. Yeah, this is the general view of the control box. Okay, inside the control box, we can see this is the compressor driver board. This control box with two compressor driver board is for big capacity. So each compressor with one compressor drive board. And on the compressor drive board is the AC current inductor. And to the right side is the single phase bridge rectifier. Yeah, this is the rectifier for fan motor. And in the right corner, this is the reactor. Two reactor. And in the right down corner, this is the DC fan drive board. We can see also two DC fan drive board. This for drive for DC fan motor. Each drive board for one DC fan motor. The inside the control box, there's two layers. The outside layers with the main PCB, and inside the layers is the compressor drive board and DC fan drive board. Okay, it's a layout. We can see we have two layout. The first one for this is both for two compressor and two fan motor. The left one is for the 18 horsepower to 28 horsepower. So these models with two small volume of compressors, we can see two compressor drive board, and one main PCB, one AC feeder terminals, and two fans, two DC fan drive board. And the right side, this for big size auto unit, 30 and 32 horsepower. These two units with adopt one big volume of compressor and one small volume of compressor. So two models, two types of the compressor. So the compressor dry bolt is different, compressor is different, and the quantity is the same, just the size is different there. Okay, you can see this is the name plate of the Hitachi compressor. For V6, we use the Hitachi scroll compressor with EVI. What it means with EVI? It means enhanced vapor injection. I think in Latin America is not. We don't need these functions, but for some countries like in Russia, in North Europe, the temperature is very low in winter season, so the EBI function is very useful. With this EBI functions, the heating capacity is very good in ambient heating. It will be increased at least 10% of the capacity in under the ambient temperature below minus 15 degree. Yeah, but in Latin America, not so low ambient temperature. Okay, we used two models of the compressor for Hitachi. We can see this table for models of the from 8 to 12 horsepower. We used one small size compressor, and middle from 20 to 22 horsepower. We used two pieces of the compressor, and we can see the difference between V6 and V6i. V6i means individual series, and V6 means modular. It can be combined. The only difference is it's only for 18 horsepower. For 18 horsepower model, we can see for V6i used one compressor, one big size compressor, and for V6 it used two compressor, two small size compressor. So only in these models is the different configuration of compressor, and the rest of the models, the configuration are the same. I mean, quantity and the models are the same, except 18 horsepower model. Yeah. Okay, this is a Y diagram for the auto unit. Models of from 8 to 28 horsepower. We can see main PCB and communication terminals, power supply terminals, AC feeder bolt, DC fan, DC fan dry bolt, and the compressor dry bolt, and other components like sensors, pressure switch, EXV, like this. So this is the general wiring diagram for the auto unit. Is for bigger capacity. It's similar. Okay. So for DC inverter principle, I think you are not you are familiar with the DC inverter principle. This is a very basic knowledge for you. I think you know where. Yeah. That's why we call the DC inverter VRF. The general principle is like this. For compressor, this is so three-phase power supply, 380 voltage AC, goes through the AC feeder and relay. So after rectify and filtering, so the AC power supply transfer to DC power. The voltage is 540 voltage. So this is AC transformed to DC. So we got the DC voltage, high DC voltage. After filtering and rectify, we go through the reactor and the three-phase bridge rectify and capacitors. So the DC voltage goes through the compressor inverter module drive. So we use the DC voltage transfer to the adjustable frequency AC power supply. So this power supply can be changeable. So we can change the voltage. That means the power supply of the compressor can be adjustable. So AC to DC, DC to AC. This is the general principle. So that's why we call it DC inverter technology, because we got the DC voltage to the compressor drive board. So the below we can see three-phase AC voltage to AC filter, three-phase bridge rectify, capacitors. We got the DC voltage to compressor drive mode. So it's not difficult to understand. I think this is a general principle. So not only media, but also Daikin, Mitsubishi, LG, they also call the DC inverter technology. Okay, so we can see the inner structure of the compressor driver. So power supply, three-phase, the voltage between the terminal P and N, the range with the range of the 450 to 650 voltage is the range. And the power supply of the compressor, UVW terminals, it can be adjustable, so changeable. So after frequency changed, the voltage also changed. So different frequency, different voltage, so we got the different capacity for inverter compressor. So this is the internal structure of a compressor driver. We can see there are different circuit. There are six types of the circuit. To A plus to U terminal and output to V to this one. So we can understand like this. The voltage can be transferred in different circuit. Okay, for fan motor, we use the DC fan motor. So three phase voltage, 380 voltage after AC filter. We use the one phase of the power supply, 220 voltage AC. We got this supply for fan motor. So this power supply goes through the single phase bridge rectifier. After rectifying and filtering, also with capacitor. Capacitor used for filtering, and a single phase bridge rectifier is for rectifying. So after that, we got the DC voltage. The DC voltage, the value is 310 voltage. This is for fan motor. So the DC voltage go to the fan inverter module. So similarly, DC voltage transform to the adjustable AC power supply for the DC fan motor. So the DC fan motor can be driven by this adjustable voltage here. It's the principle of the fan motor here. Okay, for main PCB, the power supply is like this. First, we got the original three-phase power supply, 380 voltage. We just this voltage will be the PCB, the main PCB with integrate three-phase like three-phase protector. So the power supply will be detect the phase sequence and also detect the voltage. If the phase sequence is not normal and the voltage is also value is out of the range, it will be a error code display. So after power supply detection, we used one phase 220 voltage, and also it has a fuse. Goes through the single phase bridge rectify. So we got the DC voltage 310 voltage. This is a DC voltage. There's a transformer on the main PCB. So go through the transformers. We got a low DC voltage, 12 voltage and 5 voltage. Usually 12 voltage is used for drive the EXV. This is 12 voltage. And 5 voltage is for drive some sensor, pressure switch, pressure sensor, and others. Is most popular for 5 voltage. This is the principle for main PCB. Okay, so we can see the diagram. Sorry. So the AC filter, after the power supply go to the AC filter, the rectifier and filtering to the main PCB and to the compressor driver board. This is the circuit of the power, and the bridge. Three-phase. This is a single phase bridge. We used one phase of the power supply to the DC fan motor. This is the to the another compressor drive board. The circuit like this, yeah. Okay, for the electro component, we can show you. For the main PCB of the auto unit, we can see there are different component. In the middle, we can see this is the main chips. This is the main control chips. And the right side, we can see the manual button. So for this button, 4 buttons, we can make a manual setting and check some parameters. And this is a four digital display, LED display. It can be display the error code and the value of the parameter for check button. We can check voltage, temperature, pressure, and under the menu switch, there's a DIP switch. Yes, DIP switch from some basic setting, yeah. And for function of the DIP switch, we can see the different types of the DIP switch. This switch used for send for auto unit address and auto unit capacity, auto unit network address, and we can also send for some silent mode. And the quantity of the indoor unit, online indoor unit, just combined the DIP switch, EMC3 and S12 combined. And outdoor static pressure setting, priority mode setting, just a lot of kind of the DIP switch for different function setting here. Okay, so the main PCB, we can see the down arrow, this is the power supply arrow. So this ported for 380 voltage to input the main PCB. So we got the three-phase power supply. So the power supply can be detect the frequency and detect the voltage value. So we got one phase of the power supply to rectify and filter and go to the transformers. Transformer DC 310 voltage to 12 or 5 DC voltage. This is a power supply error. And this is the center. This is the chips, the main chips. And I need to mention for the main PCB produced before June 2021, this main PCB can be programming the port. So we can use the programming port to upgrade the software. But the main PCB produced after June 2021, the software can be upgraded by USB because last year we make a upgraded for the main PCB. So after that, and the main PCB used now, we can use the USB upgraded. I think USB upgraded more convenient than the programmer upgraded. So please pay attention to this change here. Okay, the right side is the display and sending area with the menu button, LED display, and the DIP switch. The left side is value of the sound relay. So this relay for four-way valves, solenoid valves. This is strong power. On the upper area, this is for sound sensor and communication area. There are a lot of sensors like temperature sensor, pressure sensor, and communication area for indoor unit, centralized controller, and the EXV control, high pressure and low pressure switch. This is the port. Okay, for the AC feeder board, we can see this picture. So 380 voltage input to the AC feeder, and there are different circuit to compressor drive board and input of the single bridge rectifier. For the control circuit, so it have the power supply for IGBT drives and main control circuit. So for the right side, we have the DC bus voltage detection. So in case of the voltage more than 700 voltage, and the voltage lower than 350 voltage, there will be an error code. Protection for the F1 error. Okay, we can see the diagram for the port identification. So just to show how the port for the meanings for the compressor drive board. For the compressor drive board, we also have EM-Pro chips. Communication port between main PCB and the DC bus current inductor. Okay, this is the component of the compressor drive board. AC current detector connect to PCB, and the power supply from the AC feeder board, 380 voltage. EM-Pro chips. And this is the DC bus current inductor. It can be detect the current value. If the current value more than the limit, there will be an error code here. The rectifier and invert. This is the main function of the compressor drive board. So this is the diagram. Power supply rectified to DC bus reactor. So the output and input, you got the power supply for the compressor, 3 terminals of the compressor, and invertering got the adjustable voltage for the compressor. So with different capacity output. Okay, we can use the multiple meter text to the text the voltage. For example, we can text the voltage between this port P and to L3. So the voltage usually is like 450 voltage more or less. So this is normal. And for the lower arms, we can detect the voltage between these 2 terminals. Usually the voltage is between 380 voltage. In the upper arm, the voltage between also is nearly 380 voltage. Okay, as we know, the compressor drive board usually we need to replace. This is it's very easy to damage because the compressor drive is depend on many factors. For example, usually the temperature is too high and the environment is not very good because there are a lot of dust, a lot of humidity. So usually can be caused the compressor drive damaged. Usually we need to replace. As we know, usually it will be display H6, P6, H4 protection. Usually we need to replace the compressor drive board or the compressor. So regarding how to replace the compressor drive board, it's not difficult to replace. First, we need to because the compressor drive is inside the box, we need to open the first layer, and we need to remove the screws from the plastic base. And after that, we also need to remove 4 screws from the radiator. So after that, we need to open 9 plastic bucket. Okay, for the DC fan drive board, it's just similarly. There'll be a lot of port, communication port, and terminals for communication, and also have a LED for power and alarm indicator. And from the down, we can just port for the DC fan, and input port for the power supply 310 DC voltage, and also have the DIP switch. So for the single phase bridge rectifier is used for DC fan motor. 3-phase bridge rectifier used for compressor. So we can see this is a picture of the single phase bridge rectifier. So the power supply can be reacted AC input to the, we got the DC output. Okay, for the outdoor DC fan model, we can see this is a picture. Usually we use the 2 brand. First one is Weiding. Weiding is belong to media, and another supply is Yong'an. So different brand of DC fan model. The resistance is a little different. Yong'an brand is a little bigger. And this is the the collection for the DC fan motor. We connect to the DC fan driver board. We used two models of the DC fan motor for full range of the unit. The biggest size we used the 920 model. Okay, this is the typical unit wiring diagram for indoor unit. Indoor unit is not, it's simple than outdoor unit. We can see main PCB, DC fan motor, EXV, indoor EXV, and water pumps, and some temperature sensor. Okay, for indoor unit, usually we have two types of the indoor PCB. This types of PCB is for one-way cassette, two-way cassette, and compatible-way cassette, and the floor standing. Four types of indoor unit use the same shape of the indoor PCB. So the right area is the DIP switch, port, and the chips. And the right side, this is the power supply to fuse, switching power supply to and the programmer port. Okay. This is the programming port for Intel PCB. So we can use the programmer to upgrade the software for the indoor unit. This is the specification of the port of the indoor PCB. We can see different port with different functions. Usually it's 12 voltage and 5 voltage, and 3 voltage like this. For remote on-off, EXV, swing motor, for cassette, and high wall is the 12 voltage DC, and the 5 voltage is a water level switch, display panel. Is a 5 voltage, and 3 voltage is used for a wide controller communication. Okay, the functions, DIP switch with different functions. We can send the DIP switch for some basic setting, capacity, and thermal function in heating mode, and temperature compensation. Also, there's a jumper for auto restart function. If we without the jumper, it has the auto restart function, and with it means no auto restart function. So it jumps. You can remove by yourself. Yeah. Okay, for the DC fan motor, we can see this is the input for the indoor DC fan motor. This is a 5-pin port with different color. So the blue color, yellow color, the voltage is 0 to 7 voltage DC. White color 50 voltage, and the black color is for grounding. Red color is a high voltage, 310 voltage DC. Yeah. So for four-way cassette, this is another shape. We can see the outlook is different. So for four-way cassette, we have power supply input, and with the standard water pumps. This is the port for water pumps. For the main PCB, main control part, and two-way communication. Okay, the third types is for duct indoor unit, media static separator duct unit. The shape is different. And for high wall, it's different. But the basic function is similar, just the shape is different. High static pressure duct with another shape. So totally for indoor unit, the main PCB have 5 types of the shapes. Okay, so we can see the difference between the previous generation to our current generation V6. So we make some improvement for the control component. For previous generation V5X, we can see this is included a lot of small component. They are not integrated design. So rectifier and inverter with different component, and for V6 we have the integrated design. Just compressor, inverter, drive board, and IGBT. Just 2 part. Only two part. And for inverter compressor control, also 2 part, integrate 1 part. So just 1 compressor converter board. We just need to replace 1 part is enough. And for the main PCB, for V6 is a universal design. So different capacity, we use only 1 model of the main PCB. So it can be universal, used for different types of capacity. So I think it's convenient for your spare part stock. Yeah. For previous generation V5X, we have 3 types of the main PCB. And the next one is communication. For previous generation, the IPM module between main PCB it used the PWM control wire. It's very special wire cable. And the fan module between main PCB, the fan control wire is also a special cable. But for current generation V6, we use the universal RS485 communication wire. This wire is quite common. So we can see a lot of improvement for the component. Okay, that's all for my presentation. I think for V6 it's not new. So you have experience for this control part. So if you have any questions, you can ask me and discuss freely. And also, we expect our next generation. Our next generation will be released in 2 months. I mean 380 voltage in 2 months, and 220 voltage will be released in the end of this year. So we expect this new generation generation with a lot of advanced functions and a lot of breakthroughs. So we hope the training next year we are main focused on the new generation